The Procto compaction test is a laboratory method of experimentally determining the optimal moisture content at which a given soil type will become most dense and achieve its maximum dry density. The term Proctor is in honor of a Proctor, who in 1933 showed that the dry density of a soil for a given compactive effort depends on the amount of water the soil contains during soil compaction. His original test is most commonly referred to as the standard Proctor compaction test. Later on, his test was updated to create the modified Procto compaction test. These laboratory tests generally consist of compacting soil at known moisture content into a cylindrical mold of standard dimensions using a compactive effort of controlled magnitude. The soil is usually compacted into the mold to a certain amount of equal layers, each receiving a number of blows from a standard weighted hammer at a specified height. This process is then repeated for various moisture contents and the dry densities are determined for each. The graphical relationship of the dry density to moisture content is then plotted to establish the compaction curve. The maximum dry density is finally obtained from the peak point of the compaction curve and its corresponding moisture content, also known as the optimal moisture content. The testing described is generally consistent with the American Society for Testing and Materials Standards, and are similar to the American Association of State Highway and Transportation Officials Standards. Currently, the procedures and equipment details for the standard Procto compaction test is designated by ASTM D698 and AASHTO T99. Also, the modified Procto compaction test is designated by ASTM D1557 and AASHTO T180. History: Proctor's fascination with geotechnical engineering began when taking his undergraduate studies at University of California, Berkeley. He was interested in the publications of Sir Alex Skempton and his ideas on in situ behavior of natural clays. Skempton formulated concepts and porous water coefficients that are still widely used today. It was Proctor unregistered trademark's idea to take this concept a step further and formulate his own experimental conclusions to determine a solution for the in situ behaviors of clay and ground soils that cause it to be unsuitable for construction. His idea, which was later adopted and expounded upon by Skempton, involved the compaction of the soil to establish the maximum practically achievable density of soils and aggregates. In the early 1930s, he finally created a solution for determining the maximum density of soils. He found that in a controlled environment, the soil could be compacted to the point where the air could be completely removed, simulating the effects of a soil in situ conditions. From this, the dry density could be determined by simply measuring the weight of the soil before and after compaction, calculating the moisture content, and furthermore calculating the dry density. Ralph A. Proctor went on to teach at the University of Arkansas. In 1958, the modified Proctor compaction test was developed as an ASTM standard. A higher and more relevant compaction standard was necessary. There were larger and heavier compaction equipment, like large vibratory compactors and heavier steam rollers. This equipment could produce higher dry densities in soils along with greater stability. These improved properties allowed for the transport of far heavier truckloads over roads and highways. During the 1970s and early 1980s, the modified Proctor test became more widely used as a modern replacement for the standard Proctor test. Theory of soil compaction. Compaction is the process by which the bulk density of an aggregate of matter is increased by driving out air. For any soil, for a given amount of compactive effort, the density obtained depends on the moisture content. At very high moisture contents, the maximum dry density is achieved when the soil is compacted to nearly saturation, where all the air is driven out. At low moisture contents, the soil particles interfere with each other. Addition of some moisture will allow greater bulk densities, with a peak density where this effect begins to be counteracted by the saturation of the soil. Comparison of tests. The original Proctor test, ASTM D698/AASHTO T99, uses a 4-inch diameter mold which holds 1/30 cubic foot of soil, and calls for compaction of 3 separate lifts of soil using 25 blows by a 5.5 lb hammer falling 12 inches. for a compactive effort of 12,400 FTLB-FFTA cubed. The modified Procto test, ASTM D1557/ASHTO T180, uses same mold, but uses a 10 lb hammer falling through 18 inches, with 25 blows on each of 5 lifts, for a compactive effort of about 25,000 FTLB-FFTA cubed. Both tests allow the use of a larger mold, 6 inches in diameter and holding 1/13.333 FTA cubed, if the soil or aggregate contains too large a proportion of gravel-sized particles to allow repeatability with the 4-inch mold. To ensure the same compactive effort, the number of blows per lift is increased to 56. Alternative compaction testing. The California Department of Transportation has developed a similar test, California Test 216, which measures the maximum wet density, and controls the compactive effort based on the length, not the volume, of the test sample. The primary advantage of this test is that maximum density test results are available sooner, as evaporation of the compacted sample is not necessary. References: Day, Robert W. Soil Testing Manual, Procedures, Classification Data, and Sampling Practices. New York, McGraw-Hill, Incorporated PPA 293 €312. Davis, Tim. Geotechnical Testing, Observation, and Documentation 2nd edition. Reston, Virginia, American Society of Civil Engineers, 25-26. ASTM Standard D698 Standard Test Methods for Laboratory Compaction Characteristics of Soil Using Standard Effort, ASTM International, Westsons Hoboken, Pennsylvania, DOI 10.1520/DO698-07E01, IHS, Industry Standards and Regulations retrieved from http, engineers.is.com abstract Sejabar ASTM Standard D1557 Standard Test Methods for Laboratory Compaction Characteristics of Soil Using Modified Effort, ASTM International, Westsons Hoboken, Pennsylvania, DOI 10.1520/D1557-09, IHS, Industry Standards and Regulations retrieved from http, engineers.is.com abstract Sejabar. See also, Civil Engineering, Earthworks, Geotechnical Engineering, Granular Material, Publications in Geotechnical Engineering, Soil Mechanics, Soil Compaction.